Target spot is a foliar pathogen that primarily begins in the bottom part of the canopy in our reproductive stages. It starts off in some very small, dark maroon spots. And as these spots get larger, they start to coalesce, and they'll look, as they mature, they start to look more like that characteristic target pattern. So they do look kind of circular and target in shape. And as it gets worse, or you get the conditions that are right, you will start to see that start to creep from the bottom of the canopy up through the middle of the canopy. And sometimes you'll actually see it get up in the top of the canopy, and that can make IDing it in frog eye leaf spot pretty difficult. But for the most part, it likes to stay in the bottom to the middle part of the canopy. The issue with target spot as far as yield loss is concerned is not the lesions themselves, but the fact that if you do get a number of lesions and the infestation gets bad, you can start to see that premature defoliation. So naturally, as soybeans mature, they do start to slowly drop leaves in that bottom canopy as they go through pod fill and they start to mature. But what target spot does is, if you get it too early in the season, you can start to lose a lot of that leaf tissue in that leaf area earlier in the season. So they're losing a lot of that photosynthetic area where they're not able to help out with that pod fill, and they're not getting those nutrients there. So what we're doing with this trial is we're monitoring not only to see how susceptible some of our varieties are towards target spot, but we're also monitoring for resistance. And so exactly how resistance occurs. So contrary to what some people may believe, is that we don't actually just create resistance. Resistance happens because there's actually mutant isolates in the field that have a change in their genes that cause them to be resistant to a certain fungicide. I'm going to use the QOI fungicides as well as frog eye leaf spot as an example here, because back in 2010, Dr. Melvin Newman was the first one to find some resistant isolates of frog eye leaf spot to our QOI fungicides. So essentially how that resistance developed out in the field is, you can take this picture for an example. These red blocks here are going to represent a resistant isolate, whereas the blue is going to represent a sensitive isolate. So essentially what happens is, in the case of the QOIs, we'd only been putting out QOI fungicides for a number of years in soybeans. And so what you're doing is, every time you put that QOI fungicide out, you're slowly killing off your sensitive isolates, and that population starts to become more and more littered with resistant isolates. So in return, after so many years and so many applications, you've now flipped to where you just have that resistant population, and that can explain some of the product failures that we have. So our problem with target spot is it's starting to become increasingly a worse disease to deal with, and we want to make sure that we're monitoring for that resistance and that we're not inadvertently causing resistance in target spot as well. So this trial here that I'm going to talk about is done in 3 different locations. Each of our locations we'll have here in Milan, and this location is historically a high disease pressure area. This location is done in continuous soybeans. It's just ripe for disease pressure in this area. We have a grower field that we use that's usually a moderate to high disease pressure area, but it's normally done on a 2 to 3 year rotation, so it does get rotated out of beans every couple years. And then our third location is what we consider our low disease pressure area, which is just beans planted after a wheat crop that year. It's planted into the wheat stubble that's left over, and we usually don't see too much disease pressure there. Within each of these locations, we have 3 different varieties that range in what we consider susceptibility to target spot. So our first variety is going to be a susceptible variety. In this case, it's going to be, for this trial this year, it's an Asgrow 53XO variety. We have a moderately susceptible variety, so it does get a little target spot, but it usually doesn't get as much as our susceptible variety. And then we have a resistant or a tolerant variety that in the past, the reason we can do those is Dr. Kelly has some field ratings that she does every year where we look at different varieties and their susceptibility to different diseases. So that's where we get those susceptibility ratings. We use those, and that's how we build these tests. And then within each variety, we have 6 different treatments. So we'll have an untreated check, and then we'll have a mixture or combination of all of the products that you can see here. So we've got a good representation of 4 or 5 different fungicide classes, and we've got a couple different actives within each of those treatments. We put our applications out towards the end of R3, early R4. And from there, after about 3 weeks, we'll come out and we'll do visual ratings at 3 weeks. And then we'll do another set of visual ratings at 4 weeks. So what we're looking for primarily is target spot and frog eye, but we're also checking for any other diseases that may pop up or phytotoxicity from our products, as well as we're looking at just overall defoliation, because as our yield limiter, that's what's going to hurt us in the long run with target spot and not the lesions themselves. So if you want to follow along as I go through some of the yield on the sheet of paper that Dr. Kelly and them gave y'all at the very beginning, this is going to be just the target spot kind of mix and match with products. So for here in this one, this is going to be all of 2018's field rating. So this is 3 locations, 3 varieties, and all 6 treatments all put together. And we did have pretty high frog eye pressure this year, so we do have frog eye included in this one. In 2019, it's going to look a little different. We don't have as much frog eye, so it changed a little bit. But just to kind of give you an idea, we have our yield on the left-hand side, and that's going to be the blue bar going across. Our gray bar is the amount of frog eye, or excuse me, target spot, and the orange bar is the amount of frog eye. So we were able to decrease the amount of frog eye we had in the field with all the different products and mixes that we used. For target spot, we were able to statistically reduce target spot in a couple of our treatments, but interestingly enough, this single application of Domark seemed to not do as well on target spot, kind of suggesting that maybe using a mixture or a premix of products might be our best bet to control target spot in the long run. And then yield-wise, our only clear separation was this Mirvis top product. That's it's got that new STHI Depidin in it. In 2019, the data is pretty similar. So we had a low frog eye year this year. So we left frog eye out on the ratings. But again, just like from 2018, we see that that single mode of action of Domark, that DMI fungicide, doesn't seem to really work that well on target spot, whereas all of our other treatments statistically reduced the amount of target spot in the field. But then when we look at yield, all of our products except that Domark seem to increase and statistically increase yield. And then when you look at the sheet of paper that everyone has, you can see that we've broken down each of the treatments into their different varieties. So you can see how those different products react specifically with those varieties. So you can use that to better differentiate if you have a variety, how might that product react with that fungicide that you're putting out. For 2019, or for 2020, I don't have it up here on the board, but it's kind of been a low target spot pressure year. At least here in Milan, in our second location in our grower field, it's quite a lot higher, and so we're seeing a lot more target spot there. The problem there is, though, we do have some beans that are kind of laying over, and they've just kind of stayed wet and just kind of gotten humid in that canopy. From there, what we like to do after we do all of our field ratings is we'll actually look at the individual isolates themselves. So we'll go into our untreated checks, as well as we get isolates sent in from county agents, through fields, or even from growers that we take ourselves. And we want to look at the individual isolate and how they react to the technical grade version of a single active ingredient. So what we've got here is, this is just the different active ingredients that we used, and they're by themselves, they're not mixed with anything else. And then this EC50 value that you see across the top, essentially all that is that is the effective concentration in parts per million that it takes to inhibit 50% or half the growth of the certain isolate that we looked at. And so we did this with 30 different isolates. And one of the things I wanted to make note, the ones I have here in red, These three here, so our pyraclostrobin and azoxystrobin, those are those QOI fungicides that I talked about earlier. So those we do have some issues with resistance with in frog eye, and it seems that we may have a little problem with them for target spot. There also has been some talk that we may not actually have resistance, but some of those QOI products just don't seem to work that well on target spot at times. We do check these, we do some molecular studies on these to make sure that we don't see that resistant gene in these isolates. So we haven't found those yet, so our conclusion so far is that maybe some of these products just don't work as well. For thiophanate methyl, there has been some resistance concerns in Cercospora leaf blight out of Louisiana and then South Mississippi. So there could be some issues with that resistance down the road. Both of these classes of fungicides, though, do fall under our FRAC code. FRAC considers these high risk for resistance. So we do have to keep that in mind when we're trying to make our fungicide applications. But as far as management goes, how you can manage for fungicide resistance as well as for target spot, one of the major things you can do is just putting out a resistant variety or a tolerant variety. So if you have here in Tennessee, we do have on the UT Crops website, we do have a searchable database with a number of years of different varieties that you can look at to determine how sensitive that variety is to a certain pathogen or disease. The other thing too is to make sure that you're rotating chemistries, as well as if you do have to go in with a product, try to use a two-way mode of action if possible. And that can be making your own mixes, or that can be just using a premix of a product. And on the sheet you can see how important it is to plant those susceptible or those resistant varieties. We do have, over the years, we've changed up the varieties each year to get a good representation, and more times than not our resistant or even our moderately resistant variety, it keeps that target spot pressure pretty low and it yields higher or as high as some of our susceptible varieties. So always try to keep that in mind when you're looking at your different varieties.